Right, so let's take a look at parallel versus perpendicular lines in a coordinate plane, like on a graph. You've done this previously in your third, fourth, or fifth grade level, but let me just quickly remind you, what does parallel lines mean? And the way I like to remember this is, if you look at these two L's right here, it looks just like that. It's lines that never meet. They go in the same direction and the same distance apart forever. So let's get an official definition of some characteristics. They're in the same plane, they never intersect, they're always the same distance apart, they have the same slope. The symbol is this. Okay, that's very important. This is the symbol for parallel lines, and those two L's are going to tell you. Railway tracks are an example. So parallel lines, we're just going to say never meet like railway tracks. Okay, and this is the symbol for it that I've highlighted. On the other hand, perpendicular lines, okay, so perpendicular lines, they do meet, but they meet in a special way. And for this perpendicular line, I think of an upside down T, and they always meet at a 90-degree angle. So my T is curved for some reason, so let me draw it again. So upside down T, that's the symbol for it, and they always meet at 90. So they meet at 90 degrees. If it is not 90 degrees, then it is not perpendicular. All right, so now that we know the official definitions, so again, this is what they look like. They meet at 90 degrees, always in the same plane. They always intersect at 90. One slope has M, the other slope has that. This is the symbol. All right, so don't worry about that. We're going to prove that in just a second. So now that you know what parallel versus perpendicular lines look like, what do these two lines look like? All right, so you should have said that they look like parallel lines, but be careful, because sometimes they can look like parallel, but they're not parallel. That's why we have to mathematically prove it, and that's what we're going to do. So it says find 2 points and input it into a table. So boom, table. I need 2 points. So here's one right now, -1, 1. So -1, 1. And another point is marked for me, 1, 3. So 1, 3. Oh, and as I'm doing my example 1, you are doing example 2. So at this point, you should have a table with 2 points inputted. There's 1 point right there. There's another point right there. All right, so now that you have that put in, that's for line A. I'm going to repeat that process for line B. Okay, so I'm going to say line B, another table, and I need 2 points as well. So there's one right here, so 0, -3. And if you're not good with the zeros, just find another one. So let me just, find me some corners. Here's a corner right now, 4, 1. So I'm going to do 4 and then 1. And another corner right here, 6 and then 3. All right, so if you get confused that this is 0, -3, not -3, 0, then just stay away from the zeros and just find another 2 corners. All right, so right now you should have found the C and D 2 tables. Then what you want to do is click the flag button and look for the slope. All right, so I'll click the flag for line A. The flag slope says that it's 1. All right, for line B, the flag says that it's also 1. So I've got the 2 same slopes. Now I do need to answer, what is the y-intercept for A? So where does it cross the y-axis? This is the y-axis. It crosses at 2. And for B, it crosses at -3. So again, at this point, you should have found your slope for C, for D, your y-intercept for C, and for D. Can answer this question. Parallel lines have the blank slope and blank y-intercept. So based on my answers and your answers, what can you tell me about the slopes? What can you tell me about the y-intercepts? So now we're going to go on to example 3 and 4. I'm going to do 3. You're going to do 4. All right, so again, I need to find slopes. So we're going to repeat the same process. So I'm going to put in a table and I'm going to pick points. So on this case, I've got -2, 3 is a point. So as I do my question, you're doing yours. And then another point is going to be, I guess, -2, -4. Any points you want, it doesn't matter. All right, so those are my 2 points for line E. I'm now going to pick my 2 points for line F. So again, a table. Line F is, let me pick this one here, 1, -2. And let me pick one on this side, -4, -2. X and then Y, -4, -2. All right, now that I have my 2 tables, I need to find the slope. So I'm going to click. So something is wrong, because I can see that it's not going through, and this is what I'm always asking you guys to do actually, so I'm glad I'm doing a question like this. It's not hitting my points. This black line is slanted. It's not hitting my points. I'm wondering if I put in some more points, if it'll be more accurate. So I'm just going to hit some more points. So -2, 1 is another one. All right, let's hit one more. Negative 2, 5 is another one. Okay, so this is not hitting any of my points. If I hit zoom fit, you can see that is clearly not fitted. So, okay, so there seems to be an issue with Desmos being able to give you a slope of a line that doesn't exist. So what do I mean by that? You should have learned this again back in your middle school / elementary days. When you have a straight vertical line, that slope is undefined. The way I like to remember it is if there's a person at the very top of this line right here, and they jump off of this line, they're going to splatter into a million pieces and they're going to become undefined because they're going to fall to their death. It's like a cliff. Okay. On the other hand, if I have, and I'll do this one, if say we had a person on this flat line right here and they were trying to ski, they wouldn't get very far because that slope isn't what? It ain't doing anything. It's not going up or it's not going down. The slope is 0. But if you're over here at point H, for example, right, and you're trying to ski, you're not going to fall off the cliff because now you're going to slope down like this, right? Whereas if you're here, you're also not going to fall down the cliff. You're sloping up, which is why this one is called a negative slope and this one is called a positive slope. But for the two examples that I just did, right here, this is a 0 slope and this is an undefined slope. So the slope for E is undefined. And mathematically, I'm going to tell you it's undefined because you cannot divide anything by 0. Because remember, the old definition for slope is the change in y over the change in x. So if I go to slope, the change in the y over the change in the x. Okay, so y is changing, let's say from here to here. Y is changing by 1, but how is x changing? It's not. So if I put that in the calculator, y is changing by 1, but x is not changing at all. You'll see the calculator will tell you it's undefined. So mathematically, it means you cannot divide by 0. So I'm actually going to go ahead and add that. Cannot divide by 0. Okay. All right. And then for the slope f, it's going to give you a slope because it's going through the y-axis. So you'll see if I hit flag, it should tell me 0, which it does. It tells me a 0 slope and then y-intercept of -2, which is true. So the slope for f is 0. All right. What is the y-intercept for E? Where does it cross the y-axis? It does not. So we're going to say NA. And the y-intercept for f is -2. Okay, so these are my slopes and my y-intercepts. Now you're going to repeat the process for yours. Obviously, I've already told you H should have a negative slope and I should have a positive slope. So this one might be a little bit harder to fill out, but perpendicular lines have slopes that you have to something and something else, the something. The y-intercept can be different or the same because obviously you can see mine are different. All right, the math term for this is reciprocal. We can also say that when you multiply those two slopes, you always get -1. So if they're perpendicular, when you multiply them, you always get -1. Okay, and the math term is called reciprocal. So that's the word you want to see. But I need you to determine how do I find, so once you get yours, you should be able to see yours because mine's a little bit harder. But when you get your two slopes, all right, you have to do something and something else so that something can happen. So I want you to see if you can figure out what goes into those blanks. Let's practice.